Welcome everyone, it's Ada from HEARCOUNT. It's already our fourth webinar series. Today, our topic of discussion is the art of organizing datasets for efficient analysis, specifically the concept of tidy data. So alright, let's dive right in. Our webinar is titled Tidy Data Framework, where we'll unpack the intricacies of data organization. But first, a brief word about HEARCOUNT. HEARCOUNT is a platform designed for you. It allows users to upload Excel or CSV datasets, making data visualization and analysis simpler, even if you're not tech savvy. Just sign in with your Google account and access our free visualization tool. To begin, either scan the QR code displayed or check out our homepage link in the description below. Let's delve into our agenda for today. We'll start by introducing the concept of a tidy dataset, discussing its structure and unique characteristics. We'll tackle the challenges you might encounter in transforming datasets, especially when converting from wide to long formats. Together, we'll delve into the different types of dataset variables, and I'll provide some illustrative examples to cement your understanding. To wrap things up, I'll share some concluding thoughts on the benefits and expectations of working with well-organized datasets. To frame our discussion, let's acknowledge Hadley Wickham. His paper on tidy data is a cornerstone in the R community, and we'll lean on his insights today. Drawing from literature, there's this insightful line in Anna Karenina by Leo Tolstoy. Happy families are all alike. Every unhappy family is unhappy in its own way. Wickham parallels this sentiment in data organization, suggesting that tidy data are all alike. Every messy dataset is messy in its own way. Simply put, a tidy dataset makes analysis, processing, and visualization a breeze. But messy datasets? Each presents its distinct challenges. The term tidy dataset signifies data that's structured ideally for analysis. Structurally, data usually presents as rectangular grids with rows and columns. This layout aids comprehensibility and is a perfect fit for relational databases. Semantically, these rows and columns contain values that make up the dataset. Columns signify variables, while rows capture observations, the units of analysis. For instance, in sales data, one sale is the observation, whereas the sale amount or date might be variables. Every piece of data has both physical and semantic dimensions. The physical layout dictates the data's format and shape. Semantics dive deeper into the values and the underlying meanings. Consider an example. We're evaluating the effect of two drug treatments, A and B, on people like John, Jane, and Mary. But here's a question. Are these treatments variables or values? In an organized dataset, rows capture unique observations and columns host variables. Results are indexed by the individual and treatment type, making it discernible to see the outcome at a glance. Diving deeper, consider these scenarios. We aim to find a correlation between treatments A and B, or we wish to differentiate the effects of the two treatments. Which dataset layout would best address these questions? But before we delve into that, Understanding variable types is crucial. Numerical variables represent quantities and can be either continuous or discrete. Categorical variables denote categories or groups and can be ordinal or nominal. To clarify, variables hold data in numbers or letters, and analysis uncovers relationships between these variables. If you're discerning correlations between treatments, your dataset should present treatments as separate numeric variables. However, if the goal is to compare treatment effectiveness, you should view the treatments as categorical variables. Despite the general preference for tidy datasets, it's essential to mold your data to best answer your research questions. Revisiting the tidy dataset. Columns represent variables, and rows capture a set of measurements. Variables can be grouped into X and Y. In the data analysis realm, terms can vary. X might be called a features, independent variable, input, predictor, or attribute, while Y could be termed target or label, dependent variable, output, or response. And rows equate to observations, which is also called as record, sample, instance, or case, while individual data points are values. There's a quick quiz for you. Identify the best dataset to calculate the death rate per 10,000 people for tuberculosis in 1999 and 2000 by country. Okay, so did you got your answer? It's option 4. While the other formats are not necessarily wrong, but for visual clarity and pattern identification, the fourth format stands out. Understanding and leveraging tidy datasets is crucial. However, real-world data often deviates from this ideal. If all messy datasets followed a standard, tidying them up would be straightforward. But the reality? Each messy dataset presents unique challenges. I want to underscore the importance of ensuring that each column in your dataset represents distinct variables. This is really crucial for effective analysis. Additionally, it's vital to clearly differentiate between numeric and categorical variables. Laying down this solid foundation is essential as we dive into various analytical tasks. I'm revisiting this slide to ensure clarity and lay a foundation for our upcoming discussion. Modern analytical tools like HEARCOUNT, Tableau, R often anticipate tidily structured datasets as ideal for visualization and exploratory data analysis. For modeling purposes, the dataset structure might deviate slightly from EDA. EDA encapsulates description, comparison, and relationship. To extract meaningful answers, each column should consist of individual variables, allowing us to discern their distribution, mean, maximum value, and overall shape. A dataset should not merge a single variable across multiple columns or conflate multiple variables into one column. Each column must represent a distinct independent variable. For comparisons or understanding relationships between variables, distinct columns for categorical and numeric variables are essential. Effective data analysis and visualization vary with the type of variable in question. Consider this dataset. It contains two variables, wine's alcohol content and subsequent consumer satisfaction or quality. So both are numeric. However, A scatter plot of this data appears skewed due to specific scores chosen by respondents on the y-axis. This leads to a phenomenon known as overplotting. But a technique, jittering, can help mitigate this, but may introduce other biases. It's important to note that while consumer satisfaction is quantified numerically, it's essentially an ordinal scale. When exploring relationships between such a scale and numerical data, in this case with a box plot, comparing distributions across categories can be enlightening. By considering consumer satisfaction as categorical, this third chart reveals an intriguing pattern. As wine's alcohol content increases, consumer satisfaction follows suit. Let's delve into the distinction between wide and long datasets. In data parlance, melting describes the transition of a data from a wide to a long format. An example is table correlating religious group followers with income brackets. While the columns may initially indicate specific income ranges, they are more than mere labels. They are integral to the melting process. A transform table here would feature an income column with each income bracket represented as distinct rows. Such transitions exemplify a tidy dataset, something anyone familiar with Excel or Google Sheets will recognize. Right here. So, mastering the art of reshaping datasets is foundational in data analysis, and I'm going to show you a bit deeper. So this helps discern patterns and trends more transparently. So I've used this array formula to structure the wide data set in a long format here. In other words, it's on-pivoting. Actually, the second data set type enables us to assess the sales trend across different months. Whereas, it's worth noting that January, February, March, and April represent distinct variables for correlation in the first dataset. So, unless our aim is to analyze the correlation between these variables, presenting them together wouldn't be meaningful. So this approach, irrespective of the tools or languages used, aligns well with Python, R, or Excel. And interestingly, when I once sought GPT's advice on transitioning from wide dataset to long datasets, it immediately suggested this melt function in Python and also in R. So seemingly, this automation aids this process, but mastering these tools demands hands-on experience, and not everything is automatable. Delving deeper, percentiles convey where a specific value ranks within a dataset. If, for instance, you rank 4th in height among peers, you're in the 80th percentile, not the 20th. It's about those below you, not above. HEARCOUNT seamlessly transforms numerical variables into categorical ones, variables to just numeric variables into categorical ones. HEARCOUNT seamlessly transforms numerical variables into categorical ones using percentiles. The drill down function, as displayed, helps pinpoint performance metrics within the Superstore sales dataset, while copiers dominate the top profit percentile. Tables lag, indicating diminished performance. HEARTCOUNT offers other performance gauging methods, but we'll reserve that for another discussion. To identify top-tier customers, you have to consider recency, frequency, and monetary value. However, due to disparate scales or variances across these variables, standardization, like decile calculation, becomes indispensable for comparative analysis. Approaching the end, let's explore a well-organized tidy dataset with unified observations. Imagine pinpointing specifics like the net order value cancellation rate for a particular order at a precise time. Such granularity allows for in-depth insights, such as identifying peak cancellation rates for certain demographics. Okay. However, data has its boundaries. While it illuminates patterns and trends, the why behind these observations might remain elusive. Deep insights often demand domain expertise. The ultimate aim is to harness data for impactful business decisions, and recognizing data limitations is paramount. Let's dive into demonstration with a sample dataset. Click here, and I'm going to make a new campaign. I'm going to use a sample dataset, Hans Rosling dataset to illustrate. Okay, so as you can see, this dataset contains variables like country, year, life expectancy, fertility rate, population, and so on. With a structured dataset, correlations can be found. Click continue, start EDA. Okay, so for instance, I'm going to leave the y-axis as life expectancy and change the x-axis to child mortality. And you'll see a notable negative correlation that emerges between life expectancy and child mortality. And I could also break down by categorical variables such as continent here, or look at the distributions for each continent like this. So such insights become even clearer when we differentiate between numerical and categorical variables, underlining the importance of tidy dataset. In wrapping up this session, I hope the shared insights resonate with you. I appreciate your engagement, and I'm eager to reconnect with you in our 5th webinar. See you then!